Algebra 2, Chapter 2.3, Exercises 14 through 22. This section of the book is one in which we're going over solving absolute value inequalities. We're going to go over, in this video lesson, the odd number problems. And so we're going to start with number 15. We have negative 5 times the absolute value quantity x minus 3 minus 5 is less than 15. So we will add 5 to both sides of the inequality. And for that, we get negative 5 times absolute value quantity x minus 3 is less than 20. Next, we're going to divide by negative 5. So we get absolute value of quantity x minus 3. Now, we have divided by a negative number. So what do we need to do? I hope you remember that we need to reverse the direction of our inequality symbol. So we get absolute value of quantity x minus 3 is greater than negative 4. Well, this expression here, absolute value of quantity x minus 3, what can this possibly be? This has to be absolute value of quantity x minus 3 has to be always greater than or equal to 0. Could be possibly 0, but cannot be less than 0. And so therefore, there is no real number in the place of x here that is going to make this an untrue statement or untrue inequality. Therefore, our solution set for this inequality is all real numbers. And on a number line, we can just put a horizontal line segment and just adorn each end of that horizontal line segment with an arrow representing all real numbers. And now you could, solution set, you can write an interval notation, solution set. You can write it this way too. So I'll just put all the. Okay, next problem we're going to look at is 17, getting into real world problems. And when you think about it, real world situations are mostly inequalities. I need to lose 10 pounds, at least 10 pounds. I need to save $500 to buy a TV. Well, that's at least $500. So I need to obey the speed limit. So I have to drive less than or equal to 75 miles per hour. The thermostat for a house is set to 68 degrees, but the actual temperature may vary by as much as 2 degrees. What is the range of possible temperatures? So we have some temperature T, and if you subtract from that temperature 68, we have to be has to be less than or equal to 2, but can be either direction from that. So it's going to be T, absolute value quantity T minus 68 is less than or equal to 2. So this is going to manifest itself in a couple different ways. And by the way, we have a less than situation here. And what do we know about less than situations? We're talking about less is nest, which means that normally on number line, our solution set is going to be between two values. So we're going to set up two separate inequalities from this. We're going to have T minus 68 is less than or equal to 2. And also we have T minus 68 is greater than or equal to negative 2. So in this second one on the right, we had to change the direction of that inequality symbol. And now we can set about solving for T in both inequalities. We add 68 to both sides. So we get T is less than or equal to 70 degrees Fahrenheit. And for this right inequality, adding 68, we get T is greater than or equal to 66 degrees Fahrenheit. And we can combine our possibilities with less than 70 degrees, more than 66 degrees. So our temperature is going to be greater than or equal to 66 degrees Fahrenheit and less than or equal to 70 degrees Fahrenheit. And that is going to be our answer in inequality notation. And so on this number line, it's like we have, this is going to be 66 degrees here, and this is going to be 70 degrees here. And it's one of those problems that you really can quite easily answer this question as a matter of common sense. If we can go 68, really your answer can be maybe so more simply stated as 68 plus or minus 2 degrees. Well, we can figure out quite easily that we're going to have possibly 70 degrees at one extreme and 66 degrees at the other extreme. Next autonomous problem we're going to look at is 19. On average, a squirrel lives to be 6.5 years old. The lifespan of a squirrel may vary by as much as 1.5 years, was the range of ages that a squirrel lives. If you really think about it, this is quite similar to what we were looking at last time. So we can say t, we can use time. So time minus, or instead of time we can use different age, A for age, that A equals age, minus 6.5 years, and that's going to be in absolute value brackets, is going to be less than or equal 1.5. And again, we are subject to less's nest, right? So we expect to have our real range of age be between two numbers. That we'd have to have that for it to make any sense, wouldn't we? So we're going to get A minus 6.5 is less than or equal to 1.5. And then we're also going to have A minus 6.5 is going to be greater than or equal to negative 1.5. So we just have to solve each of these by adding 6.5 to each inequality. And for this left inequality, we get the age. A is less than or equal to 8. That would be years. And on this right one, if we add 6.5, we're going to get age is greater than or equal to negative 1.5 plus 6.5. That's going to be 5.0 years. So we would say age is going to be greater than or equal to 5 years. Let's say 5.0, and less than or equal to 8 years. And again, this is a common sense thing pretty much, right? You can take 6.5 plus 1.5 is going to be one extreme, and 6.5 minus 1.5 is the other extreme. So that'd be it. The last one we're going to look at in this set, 21. The speed limit on the road is 30 miles per hour. Drivers on this road typically vary their speed around the limit by as much as 5 miles per hour. So again, we have speed limit we could say speed minus 30 miles per hour is going to be less than or equal to 5. Again, we would expect to see between, and in your head, you've probably already figured this out. So we have two versions of this. We have s minus 30 is less than or equal to 5, and we have s minus 30 is greater than or equal to negative 5. And we can just solve each inequality. So s is less than or equal to 35, and then over on the right inequality we add 30. So we're going to s is greater than or equal to negative 5 plus 30, which is going to be 25. So s is greater than or equal to 25 miles per hour, but less than or equal to 35 miles per hour. So we can just say this is the range of typical speeds of typical speeds in miles per hour is, and we have our inequality right here, so that is going to be it. And this is the last problem I'm going to work out in this video lesson. Number 22 is a nice little one, a real world problem situation. Good luck, and thanks for viewing.